Okay, so I have to correct the I-class, no? So if there is a span with a concentrated load, equal concentrated load, and acting at middle thirds, okay, so L over 3 ang iyang span. So ang iyang end moments is 2PL over 9. Okay, 2PL over 9. Okay, so let us have an example. Okay, so we have this beam, no? So we are required to draw the shear and moment diagram of the beam shown. Assume B is a roller and EI is constant. So we have a continuous beam ABC with a fixed support at its end and a roller at B. Okay, so first thing we are going to do is solve for the fixed end moment. So I have already here a space for my shear and bending moment diagram. So I will start at the bottom. Okay, so we start with the fixed end moment. Okay, maklaro ba class? Fixed end moment AB. Okay, so continuous beam man siya. So imo sa nang ipang fixed end kada segment or span of the beam, no? Meaning segment or between supports. Okay, so we have first segment AB, which is loaded with a concentrated load of 25 kilonewton. So ano sa ni siyang pang fixed end. Okay, solve for the end moment at AB. So sa PCAS pod we call that BA. Okay, so this will be FEM BA and this one FEM AB. Okay, so FEM BA concentrated man na. So ang sa atong formula PL over 8. So our P is 25, our L is ang given diri is tag 3 meters. So ang iyang total length is 6 divided by 8 and this is equal to pila? Equal to 18.75. Okay. And also at the other end. Okay. Parehas sila. So this will be 18.75. Okay. And then for FEM BC, okay, FEM BC, okay, na continuous man na siya dito. So imo sa ipang fixed end ang BC. So may mo na ni siya diyang fixed ended beam. So unsa man iyang end moment from our formula, that would be WL squared over 12 equal to 15. Ang iyang L is 4 meters over 12 and this is equal to 20 kilonewton meter and this is also kilonewton meter. And FEM CB, parehas naman sila, WL squared over 12. So this is also 20 kilonewton meter. But you have to take note of our sign convention, diba? So ingon man ta nga ang end rotation is clockwise if positive. So kani ang atong AB is counter man ni, so this will be negative, no? Negative 18.75 kilonewton meter. Nya ang FEM BA positive, ang FEM BC kare is negative. Nya ang FEM CB positive. Okay, so those are our fixed end moments. So next, we write our slope deflection equations. Okay, so what is our slope deflection equation? Okay, so for span AB, so it will be MAB is equal to 2EI over L times AB man na, so musugal 2 theta A plus theta B minus 3 psi plus fixed end moment AB. Now, as given in the problem, there is no settlement of the support. So, our psi will be equal to 0. Okay. So, we have now MAB equal to 2EI. Ang L sa AB is 3 ug 3, 6 meters times 2 theta A plus theta B. Nga itong fixed end moment AB is minus pila man to 18.75. Okay. Now for MBA, okay, so that would be 2EI over L, or L is 6, and magsugod na po ka sa 2 theta B plus theta A plus itong fixed end moment during BC is positive 18.75. Okay. Now for MBC, okay, so we have 2EI. Ang length sa atong BC is 4 meters. Okay, so this will be over 4 times, so this will now be 2 theta B plus theta C. Okay, BC naman na, theta C. Nga atong fixed end moment BC is minus 20, and this will be equal to, simplifying, we have 4 over 4, that's 1, so EI theta B plus EI theta C over 2 minus 20. Okay, so hindi nato ni na simplify, no? So ato ni simplify. So this will be 4, 6 EI theta B plus EI theta B over 3 minus 18.75. Okay, so we continue. Then MCB will be equal to 2EI over L, which is 4, and then this will now be 2 theta C plus theta B. Yung atong fixed end moment CB is plus 20. So this will be equal to 4 over 4, that would be 1. So EI theta C plus EI theta B over 2 plus 20. Okay. So the next step is to determine the joint condition. Kung unsa ang mga conditions sa joints or supports, no? Okay. At joint A, okay, so at joint A, that is a fixed support. Okay? So kung fixed ang support, na ba na siya slope? Now it is restrained vertically, horizontally ang imong fixed support. So ang imong slope theta A is equal to 0. But for a fixed support, it has a moment MAB, which is we do not know yet. Okay, at joint B, that is a roller. So kung ato siyang himuan og elastic curve, fixed man eh. So 0 mo straight sa sidya, unaog tungod sa 25 kilonewton nya different siya ingon, no? Fixed man po ni dire, so 0 pod ang iyang slope. Okay, now since it is a roller at B, so you have a rotation. So naa kay slope sa B, okay, which we do not know yet. And the summation of the moment at the joint should equal to 0 to satisfy the equilibrium principle, no? So, meaning at joint B, we have MBA plus MBC. Okay? Joint B, MBA plus MBC is equal to 0. Kani man na dire joint B. So, ang moment dire, MBA plus MBC equal to 0 to satisfy equilibrium. Okay. At joint C, it is a fixed support. So, ang iyang theta C is equal to 0. Naapod siya end moment kay fixed man. So, na may moment ang fixed support. So, naa siya MBC. No? And that is MCB. Sorry. So, this is MCB. Okay, naa naman ta din So, MCB. CB is unknown yet. Okay. Now, from these joint conditions, we can go back to our slope deflection equation. Ato nang ipang substitute ang mga values dire, no? So, ang imong MAB, okay, substitute in SDE. Okay? So, ang atong theta A is 0. So, what will now be our theta A din slope deflection equation? So, that would be 2/3. 0 naman So, that would be 1/3 EI theta B plus minus 18.75. Okay? And our MBA is equal to, so ang imong theta ani mas 0. Okay? So, what will happen to your MBA? That would be 1/3, 2/3 EI theta B plus 18.75. And your MBC will be equal to, okay, and theta C also 0. So, that would be EI theta B minus 20 and MCB. So, theta C also 0. So, that would be EI theta B over 2 plus 20. Okay. So, at joint condition B, okay, so at B, diba ingon man ta nga MBA plus MBC equals 0. So, i-add nimo ning MBA ug MBC. So, we have 2/3 EI theta B plus 18.75 plus MBC EI theta B minus 20 equals 0. Okay? So, what will happen now to your equation? So, ma-add nimo ning EI theta B ug EI theta B. Okay? And that would be equal to 5/3 EI theta B. Okay, nya kanipod ma-simplify nimo and transpose it to the right. That would be equal to 1.25. So, we can solve for EI theta B equal to 0.75.